So for part 3, we're going to estimate emission coefficient and I sub s from the diode equation. Remember, I sub d is equal to I sub s e to the v sub d over nvt minus 1. Okay? And I sub d is measured diode current. I sub s is the reverse saturation current. V sub d is the measured diode voltage. N is the emission coefficient. Vt is equal to 0.026 volts. And 1 is just 1. So the way we're going to do this is we're going to pick 2 points on our curve, and you can do this at home. You don't have to do this in the lab. Let's say here's your curve. It looks like this. We'd like to pick 2 points, maybe there and there. So again, this is ID and VD. Okay, so we're going to call this point VD1, VD2, ID1, and ID2. You're just going to pick 2 points on the curve, measure those voltages and currents, and then we're going to solve this equation twice simultaneously. So we're going to say that ID1 is equal to I sub s e to the VD1 over NVT. We can leave off the minus 1 because we're squarely in forward bias. So we can leave off the minus 1. Okay? And then ID2 is equal to IS e to the VD2 over NVT, like this. So plug in point 1 into the upper equation, plug in point 2 into the lower equation, and then you divide. So we're going to say that ID1 over ID2 is equal to, you'll notice the IS's now cancel. Oops. E to the VD1 over NVT over E to the VD2 over NVT. And if you remember your algebra with exponentials, this is equal to the E to the VD1 minus VD2 over NVT. That is going to be a number. VD1 and VD2 were a number. Your only unknown is N. Solve for N. So once you get to that point, and you should get a value between 1 and 2. Okay? Once you have a value for n here, you can plug it into either of these equations to solve for I sub s. Okay? Easy? I hope so. We'll find out. Okay. Now there is an extra credit part of this lab to estimate the diode forward resistance. So to do that, those of you who are really macho and really gobbling this up, it's okay. Pick a third point over here. Now what's going to happen is this point here has a much higher current and a higher voltage. So we're going to assume that the resistance in the diode is what gives you a change, a shift in this curve. So what we'll do is we'll take our N and our I sub s, plug it into the third point. Let's call this ID3, and this point here, VD3. So we're going to say that VD3 is equal to ID, VD3, we're going to use this equation again, okay? And we're going to get a discrepancy in VD. So what I'd like to do is I'd like to turn this equation inside out and get VD by itself. So we're going to say that ID over IS, natural log, times NVT is equal to VD. We're just turning this equation inside out here. And then we're going to plug in our N and our I sub s. And we're going to get some new VD. And the difference between this VD and that VD is due to IR drop. So we're going to get a VD that we measured here. We're going to get a VD that we're calculating using our N and our I sub s. And the difference between this VD and that VD, VD1 minus VD2 over ID3. Let's call this VD3 minus VD3 prime is equal to RD. So the difference between the voltage we get using N and I sub S and the voltage that we see here, do this little shift over here, is attributed to the diode's forward resistance. So if we take that voltage difference and divide it by the current of the diode, we're going to get the value of that parasitic resistance. And so try to do that, and you can look up the spec for on resistance of this diode and confirm that this resistance here is less than the worst case resistance spec given for the diode. So there are two specs you can get for this diode, I sub S, reverse saturation current, and forward resistance, and verify that your numbers here are within spec for those. And that's it for this lab. So all that would be left to do is carefully shut off all your equipment, put everything away, and you're good to go. Now, it took us about 45 minutes, I guess an hour to do this lab, but students typically take 2.5 hours to do this lab because they come in unprepared. So my message to you is if you come in knowing what you're going to do, don't try to come in cold turkey. If you come in knowing what you can do, like me, you can finish this lab in an hour. If you come in completely unprepared, you'll be here for 3 hours. Some people don't even finish then, and we haven't even talked about equipment problems or what if you get a bad diode. Those are going to slow you down even more. If you come in late and you miss the lecture, the briefing at the beginning of the lab, that's going to set you way behind also. I don't have a lot of patience for students who walk into lab a half an hour late. I'm not going to abandon the class just to sit down with you one-on-one and get you up to speed. As adults, as practicing engineers, it's your job to get here on time. So I understand complicated lives, but getting here for the beginning where I can kind of brief you and get you up to speed on the lab will save you a lot of time. So anyway, we've been through the lab. You know what to do. Go ahead and do the lab report. If you do the extra credit, that's great. And you can, because this is on video, you can watch it anytime. You can do replays in slow motion and instant replays of things that I went through too quickly. And this should be a piece of cake. And hopefully we'll be back in lab, in person here, sooner rather than later. All right, very good. See you in lecture.